And now the highlight of this course, project that will tie almost everything together. A Python application that we will Dockerize and then create a GitLab ci.yml file which will build the Docker image, push it to our private container registry for safekeeping, and then run that image on the VPS. End result is a message posted on Zulip stream stating which backups were performed that day. Don't worry if you don't know Python. This is not the important part right now. I'll explain what the code does, but the focus here is on CI/CD. But yes, you should learn Python, Bash, and probably Go. Since this section is a bit more complicated than previous ones, I'll first explain all the steps. You remember that we've created backup scripts for our services. They are all named backup.sh. Then there are these scripts here for backing up LXCs. And then there is Borg with after.sh script. All these scripts will write results of those backups to the database. If I do mysql-e and then select star from backups.list where date is today's date, I will see all backups from today. I want to write a Python application that will do the following. Query the database to get this list of today's backups and their statuses, compare that list with a list of expected backups, and send a report to a Zulip stream. As with the do-p.com website, I'll do this outside of Ansible directory. I'll create all the necessary files for the application to work, create a project on GitLab and configure the variables, and then add a GitLab ci.yml file. After pushing GitLab ci.yml to GitLab, runner will build a Docker image, push it to a private registry, and then run that Docker image on the server. Application will query MariaDB, compare that list with its own expected state, and with the help of the Zulip bot, post a message to a Zulip stream. After that, we will schedule this job in GitLab so that it runs each morning, even though we didn't push any changes to the repository. Looking at the directory structure, you can see that we'll have a directory named backup checker with another directory inside it named app. In app, we'll have all files needed for the Python application to work, while outside we'll have helper files, Docker file for building the Docker image, and GitLab ci.yml for the GitLab CI/CD. Same as with do-p.com, I'm doing this outside Ansible directory. I'm creating backup checker directory with a subdirectory named app, and I'll open main.py inside that app subdirectory. As I said, don't worry if you don't know Python yet. I'll step through the code and give you an overview, but keep in mind that you should learn Python at some point. I'll skip imports for now and focus on this load.env. This function will load environment variables from the .env file so that the rest of the code can use them. Then I'm setting a bunch of variables such as this today and these two messages at the bottom. And then there are these which are loaded from the environment using this os.getEnv function. When application starts, it will import modules from the top, assign these variables, and then it will enter this main function at the bottom. Inside main, we first configure logging using this function. Don't worry about this, it just sets up the Python logger and log level. We then enter this try block, where we first query the database for the today's backup list, check which backups have success for their status, and sort them. We then read the local file with the list of expected backups and sort that one too. And finally, we prepare this pretty table which we will send to Zulip. We then compare finished backups with expected backups and based on a result, send the appropriate notification. If not okay, use this block of code. If okay, use this. I'll jump back to the top. Here you can see all functions we used. This one configures logging. This one queries MariaDB for the list of today's backups. This one reads local file for the list of expected backups. This one compares two lists, but the most interesting one is this send notification function. Sending notifications is built around a prize library. It can send notifications to almost any platform you can imagine, one of which is Zulip. And if you click here, you will see wiki page on how to set this all up. In short, you will need a Zulip bot with its own API key, which in combination with the Zulip organization URL and a Zulip stream will form a connection string. You'll also need a message title and a body. With all those in place, a prize will deliver your message. There are two problems here. First, if I open zulip.yml in traffic configs back in Ansible directory, you will see that the connection is allowed only through WireGuard subnet. Because our Python application will run from inside a Docker container, we need to add all Docker subnets we defined in daemon.json to this list. Save the file, open setup.yml, comment out everything else except the traffic role, save the file and run Ansible playbook. Ansible has finished, and if I go to the traffic dashboard, click HTTP, click HTTP middlewares and find the one for Zulip whitelist, I will see that the new subnets were added. The second problem is a bit more complicated. Let's say that I want to initiate the connection from outside the VPS. I want to connect to the gitlab.do-p.com. I want only headers, that is the capital I, and I want to follow redirects, that is capital L. This returns HTTP status 200, which means okay, it works. After DNS resolving and all that stuff, network packet reaches the VPS and hits the pre-routing chain in net table. It skips these first three rules because they are mail related and hits this rule, which is basically a catch-all rule that says route this packet to the Docker chain. In Docker chain, packet will miss all these rules until it hits this one, which says that if the destination port is 443, route the packet to the traffic container. Traffic will then route the packet to its final destination. We confirmed that in curl request when we got HTTP 200 response. If I do the same thing from the VPS, I will see the same result. This time, packet flow is a bit different. Because packet originated from the host itself, it enters the output chain, skips these two rules because they are mail related, and then enters the Docker chain. In Docker chain, it again goes to this rule, which routes it to traffic, and we get a response. But if I do the same thing from inside one of the Docker containers using the NSEnter trick, so this will enter the Nextcloud container and then try to connect to the GitLab, this doesn't work. Network packet again hits the pre-routing chain in net table. It then goes to the Docker chain, but there it hits this rule. It says that if the interface is Docker bridge interface, source is anything and the destination is anything, return this to the previous chain. This rule was skipped before because interface was not Docker bridge interface. After returning to the pre-routing chain, and because there are no more rules to match, it then goes to the filter table input chain. If we take a quick look, we will see that there is no rule mentioning port 443 or port 80, and packet is then dropped because policy is set to drop. Let's go and add the necessary rules. Open iptables.rules inside security files directory, and under filter table add these rules. So if source is any of the Docker subnets, and destination is a public IP address of the VPS, and zulip.do-p.com will resolve to a public IP address, and destination port is either port 80 or port 443, allow that. Now these packets will no longer be dropped, and because port 80 and port 443 are mapped to the ports inside traffic, packets will end up where they should. Save the file. Open setup.yml, make sure that only security role is active, save the file and run Ansible again. Ansible has finished, and I had to wait a few moments for GitLab container to come up because we have that handler that will restart Docker service after messing with IP tables. Now, if I try to run the ns-enter command again, it will work. With all that sorted out, we can now save the main.py file and open .env file also in app directory. dbhost is the additional loopback IP on the VPS, which will be reachable from inside the Docker container. If you were running this application on a different server, you would need to use a publicly reachable IP address and make sure that the MariaDB server will allow such connection. For database user, I will use backup script, I will configure user password, database, and table. There's another problem though. Backup script user is not allowed to connect from IPs assigned to Docker containers. In Ansible directory, open users.yml inside MariaDB tasks directory. As you can see, user backup script can only connect from localhost and WireGuard subnet. We need to add this segment for each of the subnets defined in etc docker daemon.json file. I'll paste this from the snippet, and all Docker subnets are now covered. Save the file, and because we already have IP tables rules that allow connection to port 3306 from these subnets, we can open setup.yml, leave only MariaDB role, save this file too, and run Ansible playbook. Back in .env, Zulip organization is the URL of your Zulip server, and for stream I will use VPS. In order to send a message to a stream, you must first create it. In Zulip, click the plus sign next to streams and click create a stream. Stream name is VPS. I will make it private and click create. For topic, I will use backups, and Zulip bot name will be do-bot. Let's go and create it. To create a bot, click on menu, click personal settings, in the sidebar click bots, click on add a new bot, choose a generic bot, full name will be do, don't worry too much about email, and click create bot. Your bot will appear in active bots tab. Copy the API key and go back to the terminal. So even though we typed in just do for the bot's name, for interacting with the API, you always need to add -bot at the end. Paste the Zulip bot API key. Save the file and open expected backups also in app subdirectory. This list represents hosts from all backup scripts we have for services, LXCs, and Borg. Save the file. Another thing missing for this application to work is all the libraries I've imported at the top of the main.py file. Inside backup tracker app directory, I first need to create a new virtual environment. I mentioned that I have a function called venv, which will create a new virtual environment named venv, activate it, and then upgrade pip inside it. You can see that the virtual environment was activated, but you need to note that this one is different than the one we use for Ansible. If I do pip freeze in the one we used for Ansible, I will see some packages installed. If I do the same thing here, there are no packages installed. By the time you'll watch this, I'll create a so-called requirements.txt file, so you can do pip install -r requirements.txt and all the necessary packages will be installed. I don't have that file yet, so I'll install packages manually. Requirements.txt is just a snapshot of pip freeze, so to create one, you do pip freeze and then output that to this file. We can now test our application by running python main.py. Looking good. If I go to the Zulip now, I will see that there is a new message in the VPS stream, and in backups topic, I can see the report.